Welcome, and a big thank you to Melissa for taking us through the P&D code requirements. I want to talk a bit about stormwater for small scale developments. We have put together an online tool to help projects meet the requirements of the P&D code. It's called InSite Water, and it really is about redevelopment and development of existing sites and demonstrating that the integrated water management requirements of the planning code have been met. Now, this is the website address of the water sensitive SA tool. Do be aware that there is an Australia-wide tool that will not work in South Australia. You will need to go to the water sensitive SA version, and you can find that link on the water sensitive SA webpage. Now, the issue that we are addressing is that business as usual can deliver this. Essentially, redevelopment that is paved and impervious from fence to fence. Now, if you can imagine the difference between a big pervious backyard and a redevelopment where rainfall hits these roofs and paved areas and runs straight into council drains, you can see that a lot more rainfall runs off when a site is redeveloped, both in volume and flow rate and in terms of the pollutants running off the site as well. And this puts huge pressure on existing drainage systems and on council assets. It's very difficult to replace underground drains, and redevelopment of this sort creates a big burden on existing infrastructure. The same goes for commercial and industrial development that just completely makes the site impervious. Now, there are a lot of ways to be doing this development that takes responsibility for the stormwater and reduces the impacts of development, both in the volume and the flow rates, and also the water quality of the stormwater that comes off the site. So here we have the new Australian Rainfall and Runoff Guide, the ARNR 2019. It was republished in 2019. Engineers Australia did a major rewrite, in fact, the first major rewrite of this guide since 1987. And it's a very important document for anyone involved in stormwater in Australia to be looking at. This is a comparative study we did. A few disclaimers is that it is a few years old now, and also that not all of these councils specifically have detention or retention policies for all building types. So these numbers, I guess, don't quote me on it. It was, I guess, illustrative though that the different requirements, I guess, of needing to store a 1 in 100 year storm or the different rainfall events, and also guidance on things like time of concentration does vary the storage requirements considerably, and sometimes that is responding to local drainage issues and constraints. I shall move on though. Now, I don't think you saw this one, so this is a simplified diagram of what I'd call a traditional on-site detention pit. It's not encouraged under the new Australian Rainfall and Runoff Guide because it does only meet one of our 4 criteria. It doesn't harvest or infiltrate water or improve water quality, but it is a useful tool for managing peak flow rates, and that you can very specifically create an orifice and a specific permissible site discharge flow rate out of the orifice. That can be engineered. Normally you'd have a trash screen, a bit of a sump as per AS 3500. The storage itself normally happens in 900 millimeter pipes, which can be quite long, and you'll probably have some entry pits as well. So this is, I guess, a traditional on-site detention system. less traditional on-site detention is that you can actually engineer gravel storage, maybe even up to a 1 in 5 year storm under pervious paving. Pervious paving also reduces OSD requirement because it reduces the area of imperviousness directly connected to council drainage systems. So you're effectively improving the post-development runoff coefficient of a site by installing pervious paving. But when I say pervious paving, it's important that you don't just have pavers or a proprietary pervious system put directly onto compacted clays or builder's soil that are full of clay and silt. They won't function very well if this sub drainage in a pervious system isn't there. We'd recommend you'd have some sort of transition layer and some gravel storage in the bottom that gives the stormwater time to infiltrate into the subsoil and provides some storage, maybe storage volume for a 1 in 3 month storm. Best practice is also maybe to have some agricultural drainage in there just to prevent complete saturation of subsoils, which can cause issues. So I want to talk about the quality objective. So this is the third of our 4 objectives as outlined by the Planning and Design Code and also the Australian Rainfall and Runoff Guide. So in the tool we've used nitrogen as a proxy for the other pollutants. Probably important for the coastal and stream ecology is total suspended solids as well, or muddy suspensions. But nitrogen is useful. It's a soluble pollutant. So if you can remove the nitrogen, you can be fairly certain you've removed everything else, including the phosphorus and litter and the gross pollutants. So we use, I guess, a 45% nitrogen reduction target as the benchmark in the tool. So I guess the classic tool for removing nitrogen is our rain garden or bioswale. And by a rain garden or bioswale, we generally mean something like this. It has a vegetative layer at the top. There'll be a soil layer to support the vegetation. There'll be a transition layer to stop the soil being removed from the system, and then there'll be a gravel storage area. And most of the work for nitrogen removal actually occurs in the gravel, where you might have essentially slime or biofilm, as we call it, eating the soluble pollutants. But this creates great filtered flows. And there are lots of different designs for rain gardens and bioswales, but we've put some suggestions, I guess, for minimum standards, such as having an overflow pit into the tool. So the final of the 4 criteria is water efficiency. Once again, this only really becomes valuable in times of drought, but I know from our experience in Melbourne, the push for having more water tanks and better water efficiency in Melbourne, according to meta-analysis done by Peter Coombs, is that we've essentially avoided 2 additional desal plants or a major dam in the last 10 years, as we've added an extra 1 million people. So this stuff does add up, and over time it does have a huge benefit at a city scale. We use the WELL scheme, which is the water efficiency labelling scheme. Pretty much any tap or toilet or fitting that you buy at Bunnings or anywhere else will have one of these WELL stickers on it. So it's very clear for the building industry when we specify a WELL's target, whether the various things they're choosing meet these requirements. The approach we've used is similar to Green Star or other water calculators out there, and it uses a water tank continuous simulation of about 10 years of data to get good a good approximation or good prediction of how a water tank will behave. Now, we've built by default some minimum requirements into the tool, and generally the defaults usually don't need to be changed, but if people are doing green buildings, they can do best practice and improve these specifications. All right, so essentially that is, I guess, an overview of what the tool does. Now, it can be used for specific purposes without the other elements. So, for example, it can be used purely to specify an on-site detention system without necessarily specifying these other metrics. However, once again, I'll just emphasize, to meet the requirements of the Australian Rainfall and Runoff Guide and the multiple objectives in the Planning and Design Code, it is better to take an integrated approach and try and meet all of these requirements and optimize your system. I'll do a demonstration run through of the tool and just, I guess, show you how you can optimize a design at the planning stage or the schematic stage for meeting these multiple criteria. Now, feedback from the testing that we've done is that once you've used the tool a bit, it takes probably about 20 minutes to take a project through the tool. So it's really designed to be quick and as straightforward as we can make it. And also just to have all the defaults in there so that even if you don't really change much other than put your site sizing in, you'll still get a good result. So how we use the tool is that we go to this URL, which is watersensitivesa.insitewater.com. If you Google it or go through the Water Sensitive SA website, you'll be able to find the tool quite easily. Once again, just make sure that you are using the South Australian version. All right, so how it works is you need to register for the tool to use it. Registration is free, and using the tool is free in South Australia. It's sponsored by Water Sensitive SA and the state government and various government agencies, and also the Water Sensitive SA partners. And how it works is you go to My Projects, and you just create a new project, or you can edit one of your old projects. Now, for today, we're going to take a case study of just a fairly intense townhouse development. So a fairly standard design. Here we've got a simplified diagram. We have a couple of deep soil zones, a bit of visitor parking out the front, and a driveway. We've got 8 double-story townhouses on quite a small block, so it's 1,180 square meters. And we want to try and get this townhouse development passing all our integrated water management objectives. So how we do that is we start by entering the details into the tool. We select a council. I'll just pick a random one, or you can put not available. But let's do Gawler, just for no good reason. Now, when you select a council, it will automatically bring up 20 years of localized rainfall data, and also the 2016 IFDs, the intensity, frequency, duration curves for your site. And we'll put in the site area, which in this case is 1,180 square meters. We'll tell it what sort of development it is. And we can put in an address using Google Maps. And let's just say it's a development off to the side here. You drop this little pin around to pick your site. And you can see that some of these sites have already been redeveloped, like these ones, so we'll pick one that hasn't. And you can, I guess, use this function to have a nice look at the existing site and its conditions. All right, if any councils are interested as well, this will geotag this site for later meta-analysis in your GIS system if needed. So have a chat to Mel if you're interested in that. Now we then put in the floor area of the site minus the garages. So this site has about a 360 square meter, we'll call it double story, plus garage. And so let's just put about 750 square meters of people in here. All right, sorry, I should be looking at, yeah, so we have a question about maintenance. I'll come back to that, some of these systems as well. And Melissa's answered that. So we need to work out basic building occupancy because that lets us work out our water balance for our site. The number of people in the building will determine the demand and the drawdown on the tanks. So this is a really simple calculator to try and just estimate occupied average occupancy. So once we've got our site details, we come back to this reminder that we're doing multiple objectives using different techniques for the different systems, and we find that things like rainwater tanks will provide outcomes for multiple objectives. However, depending on the specific circumstances, some councils might choose to ignore things like volume or quality, depending on local constraints and stormwater objectives. But how we use it is we essentially just enter our impervious areas into the tool. So we start with a roof connected to a tank, and immediately it'll bring up this simplified diagram of a water tank system, and this might also get reflected in the report that's printed. So we can say all roofs. There's no reason to put every separate roof. The tool does sum up the different pervious areas for the roofs anyway. So we can just say all the roofs. And if we have a look here, we've got 360 square meters of roofs connected to water tanks. So 360, and we'll start with about 2,000 litres per dwelling. So let's start with 16,000 litres, and we'll leave the detention tanks, the detention for now. But it does support tank-based detention or underground detention. We then add another impervious area. So in this case, we might have roof not connected to a rainwater tank. And if you add up these areas, it comes to 20% of the downpipes we found just couldn't quite easily be connected round to these water tanks. So that's 90 square meters. And we can add a treatment or not, but we'll leave that for now. But you could say put little planter rain gardens underneath those downpipes. All right, so as soon as you've done that, the tool will start running its water balances. We still need to add the driveways though. So we add another impervious area, driveway. From our maps here, we can see that's 205 square meters. Common driveway, and we can put a treatment on that. In this case, we're doing pervious paving, and you can see as soon as we put in the treatment, it comes up with this simplified engineering diagram, depending on which system you're selecting. But in this case, we're going to try pervious paving as one of the lowest maintenance systems, and we'll make most of that pervious. We can then maybe add a little bit more paths connected to drainage. So if some of these paths actually had a drain in that connected to legal point of discharge, you would put them into the tool. So I would say other paths and courtyards, pervious area, we had 180 meters squared, and at the moment there's no treatment, or you can leave this blank. We also had some pathways that are just sloping off into garden beds. And also garden bed areas can be excluded from the tool because they're not connected to any council drainage assets. All right, so that's the main bit of work we need to do, is just adding these impervious areas. After that, we scroll to the bottom and it shows you whether you've achieved your multiple objectives. And in this case, we have, just by putting some pervious driveway in and some water tanks in this case. Now, there are different ways of doing this depending on council specific requirements. So, for example, if we didn't want to do pervious paving, we would find that we no longer meet our quality objectives or our peak flow objectives. So we might do a different approach and maybe put a small rain garden either on the driveway or an above ground rain garden on the downpipes with a total of about 5 square meters. And we see that that would also pass our quality objective, but it doesn't meet our peak flow objectives. So this is our site storage requirements using a retention approach. So in that case, we might add a bit of detention storage to the top of these tanks, maybe 250 liters per tank, for example, which would be about 2,000 liters here. That would be making sure that there's dedicated detention space in the top of these little water tanks. And then we find, once again, we've passed all the multiple criteria. Now, into the tool, we do have some additional customizations and settings depending on local conditions, because not every project's going to be the same. So I'll quickly take you through those. The main one is the rainwater tank settings. Some projects might opt to only connect to a toilet, in which case you can see that their quality result and volume result is not achieved. But, you know, for example, someone may opt just to connect to hot water. Unlikely, but we've put that in as a flexible approach. You can also look at irrigation and, you know, find out that, you know, irrigating's not necessarily a good use of water tanks. It tends to mean that a lot of the time the water tank is overflowing, and therefore it's not very good for stormwater flood prevention or downstream volume attenuation. So for small urban tanks, we'd actually probably discourage irrigation only. And that's reflected in all our scores down here. But it does let people, I guess, play with their designs and work out the best solution for a site. For high-rise apartments, you might only decide that 50% of the occupants will be connected to the tank, and that's okay, but once again, it will be reflected in your scores. What we're trying to avoid with this graph mainly is seeing this pattern here that I would call a vampire tooth kind of effect. If the tank's overflowing all the time, and you can see the percentage overflow, what that means is that it's not doing a particularly good job for flood prevention. It means every time it rains, the water's basically just overflowing into a downpipe. What we want to see from our urban tanks, if it's going to have a good integrated water management outcome, is good use of the tank filling up, draining, filling up, draining. And we really want to get this overflow down below about 25%. If it's going to also be used for flood control and retention. All right, so that's our rainwater tank settings. We also have water efficiency settings. So for example, If you have a green building, you might have more efficient toilets, and that will be factored into your calculations. Weirdly, though, there's a perverse outcome. A less efficient toilet will actually give you a better stormwater score by diverting more water out of the stormwater system into the drainage. But 4-star, for example, is a good use. Is a good balance. The next box I'll show you here is that we do cater for a recycled water source. There are a couple of recycled water sources in Greater Adelaide, and if you tick that, or if you have a grey water or wastewater recycling system on site, it will factor that into the calculations. A more, I guess, interesting approach for some of the councils with existing policies is the options for different flow calculations here. And what I mean by that is we have a few different options. So the default option is a volume retention option, and that is capturing the difference between pre-development and post-development volume for a 1 in 5 year storm, based on John Argue's method from the University of South Australia. We also offer yield minimum. So this is recommended for drainage systems that are already over capacity and drainage systems that are basically stuffed and not coping very well at all with new development. So the yield minimum will aim to capture the full volume of a 1 in 5 year storm on the site. From a statistical point of view. If you want to know more about this, we've got the link to the user manual. And this user manual really will go into depth, I guess, about what we mean by these different options. So take some time and read the manual, as they say, RTFM. So getting back to the projects, we can put in on-site detention as an option. So if your policy is on-site detention and you still really want applicants to do on-site detention, you can request this. And generally it'll give you a bigger volume, we find. But completely valid if, once again, your drainage system is having issues, there are pinch points, or you've done the drainage models and that your local pipes can only cope with a certain flow rate. So if you are doing on-site detention, there are various other options. So the civil engineers in the room will probably find this interesting, and for everyone else it's a bit esoteric, but you can set the pre-development fraction impervious. So say your drainage system is designed for quarter-acre blocks, you can put that in there, 0.35. If you're designed for rural, you can put 0.2 in there. Or if it's, say, industrial and it's already designed for an imperviousness of 80%, you can drop that in there as well. Do bear in mind this has implications for the size of the OSD tank that you're specifying in cubic meters. But by default, it's set to 0.4. We also have some other settings. So we have the pre-development design storm. Some councils may say a 1 in 5 year ARI or 20% AEP pre-development storm. By default, it's set for a 1 in 10 or 10% AEP. And you can have the post-development detention storage requirements. So in some very high-risk sites where there's no overland flow path, some councils do specify this as a 1 in 100. And this is a time when these volumes will actually get quite high. But by default, it's set for a 1 in 10 year storage requirement for OSD. Now, if you wanted to, say, put a lower time of concentration than the default 30-minute time of concentration, you can do this by specifying your own permissible site discharge. Some councils will specify this anyway for planning applicants, and changing some of the other parameters essentially just give you a different PSD. The bigger the number in litres per second, the smaller the storage. So just beware of people trying to game this PSD override. If you're designing for, say, a very large catchment with a very large time of concentration and a very small PSD, you can also put that into the tool and it'll give you a very large storage. So I'll just point this out because there is flexibility, I guess, to use this tool in pretty much any policy setting for on-site detention or retention. All right. Happy to, I do need to move on, but happy to go, I guess, into more depth within house training. Talk to myself or Melissa if you're interested into really going into the engineering of this. If you did still get to the end of this and find you weren't quite meeting requirements and wanted to use an on-site detention system, you would add that in down the bottom here of the tool, and your target flow rate, that's in cubic meters, so, and this is in liters, so we'd say, 7,700 additional site storage, and if someone enters that, it immediately brings up this simplified diagram of an OSD tank so that they know, I guess, what they're getting themselves into if they commit here, and that will allow us to pass all the objectives. All right, so once you're happy with the design, you can save the project and go to reporting. This brings us up to, I guess, some of the self-certification reports that can be issued to council. So the tool can do two types of self-certification reports. One's just a certificate report, which is a very basic report. It's kind of a cut down report, but it does give the builder enough information to actually go and build the design that that's been worked through. So you just select that, select your project, and it'll create a PDF which you can then download and use as, I guess, a certificate. And it does tell you, I guess, what your impervious areas are and what they're connected to. And it does also provide, the specifications for the rainwater tank and what we've done for the well settings, basic occupancy and that sort of thing, and provides these simplified diagrams for applicants to really help, I guess, the project as it moves on to understand what it is that they've actually committed to. So there's that. For analysis, and particularly if you're an engineer or a council trying to interpret these reports, there is the calculation report that provides a bit more detail, and this lets you check the inputs to the tool in a bit more depth, and therefore it'll give you a bit more confidence that the defaults or the specific council requirements have been adhered to. So once again, it'll tell you quickly whether things pass. It'll specify impervious runoff areas, rainwater tank, and efficiency specifications, but then it will provide the detail of the stormwater quality calculations, things like the flow strategy used, what the defaults were that were input into the tool, pre and post development runoff coefficients, that sort of thing. All sorts of great civil engineering information, including PSDs and critical storm durations, rainfall intensities, all that kind of stuff. And then it's got this table of your OSD Boyd's equation inflows and outflows for the different design storms. So this is really, I guess, giving you a bit more of an insight into the back end of the tool and the rational method calculations we've done. At the end, it'll still provide the simplified diagrams for applicants so that they know that you know that they know what they've committed to.
And I'm just putting in a question for everyone about whether the detailed report should be provided every time, particularly the local government people who are online. Do they think that the detailed report should be provided every time, or is there a circumstance when the simplified report would be enough? So, you know, finding is checking your answers now verbally, or just add to the chat if you like, everyone.
I can mention as well is that there is a little bit of flexibility if you find there's something the reports don't do that you'd like them to do. Let Melissa know, and we'll consider it in our next upgrades.